Welcome back to the deep dive. Today we're staring down a paradox.
A pretty massive one.
Right.
Yeah.
And I don't use that word lightly. Usually when we talk about engineering, especially data engineering, which is, my bread and butter, we talk about trade-offs.
Oh, always.
It's the classic iron triangle, right?
Yeah.
You want speed, you sacrifice stability, you want massive scale, you probably have to sacrifice simplicity.
Yeah, you can't have it all.
Exactly. But today, we're looking at a concept that tries to reconcile two things that by definition really shouldn't work together at all. We're looking at this tension between inference and unlinkability.
It really is a fascinating contradiction. We are diving into a source titled Unlinkable Inference as a User Privacy Architecture. This is coming out of the Open Anonymity Project. And right there in the title, you have that tension you mentioned.
Yeah.
It's almost like saying dry water or silent noise.
That's exactly it. Unlinkable and inference. To me, those feel like, I don't know, magnets with the exact same polarity, just aggressively pushing against each other.
That is a really great way to visualize it. Because if you think about the fundamental nature of data science, or AI, or just basic analytics, really, inference is entirely about connection.
Right.
It's about learning. It's about taking discrete data points, connecting the dots, and saying, because of X, Y is true, it's an additive process.
It builds context over time.
Exactly. It builds context.
Yeah.
To infer something deeply personal or accurate about a user, you typically need to know the entire history of that user.
And then on the other side, you have the word unlinkable, which is the exact opposite of everything you just said.
Precisely.
Unlinkable means severing ties. It means deliberately breaking the chain of custody so that you literally cannot tell where the data came from.
Yeah.
So essentially, the mission of this deep dive today is to unpack a guide on how to learn everything about a user's behavior while mathematically knowing absolutely nothing about who that user actually is.
Right. And what makes this specific source so interesting, and why I think it's completely worth this deep dive for you listening, is that it frames this not just as a math problem.
Yeah, it's not just a white paper equation.
Exactly. Or some clever algorithmic trick. It frames it as an architecture.
That word stood out to me too. User privacy architecture.
It really implies that privacy isn't just a feature you sprinkle on top at the very end.
Like a garnish on a plate.
Right, like parsley. It's the foundation. It is the structural integrity of the building itself.
Mm-hmm.
If you don't pour the concrete right on day one, the whole thing collapses. You simply cannot patch unlinkability into a system that was fundamentally designed for tracking.
You really can't. So our mission today is to unpack this blueprint. We're going to look at what the Open Anonymity Project is actually proposing here. How do you build a system where the machine gets smarter, but the user stays invisible?
And we are going to try to do it without getting hopelessly bogged down in the cryptographic math.
Yes, please.
We'll focus on the blueprints instead.
I love that. Let's look at the blueprints for the invisible house. But before we get into the solution, this unlinkable inference, we have to talk about the status quo.
We have to set the stage.
Right. We need to understand the problem we are actually trying to solve here. Because in my world, in the very practical engineering side of things, linking is usually the goal. It is the holy grail.
Oh, absolutely. The entire digital economy as it exists today is built on linking.
Right. If I'm building a recommendation engine or a fraud detection system, or honestly even just a simple login flow, I'm desperately trying to link things together.
You want to close the loop?
Yes. I want to know that the person on the mobile phone app is the exact same person who logged in on the laptop 3 hours ago. I want to know that the user who bought the running shoes is the same user who was looking at athletic socks 3 days ago.
We call this identity resolution in the industry.
Or
Session stitching.
stitching, right.
The entire modern web is essentially a giant, incredibly efficient machine designed to create persistent identity for you across time and across space. We are trying to build what marketers lovingly call the golden record.
The golden record, which sounds majestic, but is actually kind of terrifying.
A little bit. It's a single comprehensive file that theoretically contains every single digital interaction a human being has ever had with a brand or platform.
And look, I'll be honest. From a purely systems perspective, that sounds beautiful.
As an engineer, you love it.
I really do. If I'm the database admin, it's so clean. Everything is normalized. Everything has a highly specific foreign key. There's no duplicate data.
It is extremely efficient. but it creates a massive, practically indefensible surface area for privacy failure.
Yeah, when you put it like that, it does sound like a ticking time bomb.
Well, it is, but from a pure utility standpoint, it has historically been necessary.
Yeah.
If the system cannot link your past actions to your current actions, it literally cannot infer what you might want next.
Because inference relies on context.
Exactly. And usually, historically anyway, context relies on identity.
So the standard architecture we're all used to is essentially collect everything.
Everything.
Every click, every scroll, how long you hovered your mouse over the checkout button.
The micro-interaction.
Right. And you tag all of that with a unique user ID.
Mm-hmm.
You store it in a massive data warehouse. Or probably a data lake these days because, let's be real, nobody has time to organize it anymore.
Just dump it all in the lake.
Just dump it in and let the compute figure it out later, and then you let the machine learning algorithms just run wild on that linked data.
Correct. And that is exactly where the privacy failure inevitably happens. Because once you have that richly linked history, that graph of a user's entire digital life, you can start to infer things that the user never explicitly told you.
Right. You figure out they're pregnant or they're going through a divorce or they have a medical condition just by the ambient pattern of their data.
Exactly. And even if you anonymize the name...
That's the classic move.
Right. The classic, oh, we hashed the email address, so it's fine.
It's totally anonymous now. Trust us.
But even if you strip out the email and just use a random alphanumeric string, the pattern itself is unique. This is the linkable trap that the source talks about. If the inference is strong, the re-identification risk is extremely high.
Because the pattern is the fingerprint.
Exactly. There have been numerous studies showing that you only need a handful of seemingly innocuous data points, like a few location pings and timestamps, to uniquely identify almost anyone on Earth.
Which brings us to the massive pivot in our source material today. The Open Anonymity Project is proposing this concept of unlinkable inference.
It is a genuinely bold proposition. It fundamentally challenges everything about that status quo we just described.
It still sounds like an oxymoron to me. Like, in strict engineering terms, if I walked over to my database admin right now and said, hey, I need you to set up a cluster where all the records are completely unlinkable,
What would they say?
they would look at me and tell me the database is broken.
Boss, the primary keys are gone. I literally can't join the tables.
Exactly. I can't run a single query. The whole system is down. But here, the Open Anonymity Project is aggressively arguing that this broken state is actually the main feature. They are saying we need to deliberately design systems where the inference, the output, the prediction, the actual utility of the tool happens in a way that mathematically cannot be traced back to the input identity.
And that subtle distinction is the absolute key to this whole thing. They aren't saying don't do inference.
Right. They aren't anti-tech.
Not at all. They aren't saying stop using AI or go back to dumb terminals or stop personalizing user experiences. They are saying we desperately need to decouple the insight from the identity.
Okay, so let's get into the real deep dive here.
Yeah.
We need to define our terms properly if we're going to actually understand how to build this architecture. You're the researcher here, so break down inference in this highly specific context for us. What distinguishes it from just, I don't know, looking up a row in a table?
So when the Open Anonymity Project talks about inference here, they are definitely not talking about a basic database lookup. They are talking about the system deriving entirely new information.
Okay, give us a concrete example. Let's ground this for the listener.
Sure. A database lookup is, what is the user's home address? The database goes to the row labeled user 123, it reads the address column, and it returns the value.
Simple retrieval.
Right. That is retrieval. That is a recorded static fact. Inference, on the other hand, is asking the system, based on user 123's driving patterns and search history over the last 4 weeks, where are they highly likely to be at 6:00 p.m. next Tuesday?
Okay, I see. So one is just reading a recorded fact off a hard drive. The other is making an active prediction based on synthesis.
Exactly. Inference is the act of drawing a conclusion. It is the smarts in your smart devices. It's the ability of a system to categorize, to predict, or to analyze future behavior based on past inputs. And in this proposed architecture, they absolutely want to preserve that capability.
They don't want to make the system dumb.
Right. They still want the network to be able to say, hey, this specific user profile looks like they would really love obscure 1970s jazz music. Or this particular spike in network traffic looks exactly like a zero-day security threat.
But they want to do all of that without the linkable part.
Right. Unlinkable in the context of this source is a very strict, non-negotiable privacy constraint. It means that if an attacker, or even the system admin, looks at the final output of the inference.
The prediction itself.
Yes, the prediction. If you look at the prediction, you mathematically cannot reverse engineer it to find the specific real-world user who generated the underlying raw data that led to that prediction.
So the arrow of data only points one way.
Ideally, the arrow completely dissolves the second it hits the target. You get the business benefit of the aggregated data, but you permanently lose the trail of breadcrumbs leading back to the person.
See, this is where the word architecture from the title really comes into play for me. User privacy architecture. To me, as someone who builds stuff, this screams structural engineering.
It's all about the scaffolding.
Exactly. It tells me this isn't just an algorithm you casually run on a laptop in a Jupyter notebook. It's a holistic way of building the entire system. It's the plumbing, it's the wiring, it's how the servers talk to the load balancers.
Yes. It implies, very strongly, that you can't just fix this with a clever Python script. You have to fix it with systemic design.
I was actually trying to come up with an analogy for this earlier because explaining how you can have the message without the messenger is incredibly counterintuitive.
It's notoriously hard to visualize.
Right. So the best I could come up with, and hear me out on this, is a very strange, highly secure, deeply paranoid post office.
Okay, I am ready. I love a good analogy, assuming it holds up under pressure.
I think it does. So imagine a post office where you are trying to send a letter. Now, in a normal linkable system, which is essentially how the web works today, you walk in and the post office immediately looks at your return address.
They log it in their system.
Right. They log it. They track exactly which sorting facility it went to. They create a massive graph of your social network based on who you mail things to. And they know exactly who sent what to whom at what time.
Right, standard tracking. They hoard the metadata.
Exactly. They stamp it, they scan it, and maybe they even sell that metadata to a third-party billboard company.
Which is very much the current reality.
Right. Now, in an unlinkable inference architecture, the physical building looks completely different. You walk in with your letter. But before you can even talk to a clerk or hand it over, you were forced to walk into an opaque, soundproof booth in the lobby.
Okay, I'm with you.
Inside this booth, there is just a machine. You feed your heavily sealed letter into the machine. The machine physically opens the letter inside its own little black box, and it reads the actual contents.
Okay, so this is where the inference is happening.
Yes. The machine reads the letter. Maybe it's doing a security scan for dangerous items, or maybe it's just categorizing the intent. It says, okay, this is a happy birthday card, or this is a past due electricity bill.
It extracts the utility.
Right, it gets the metadata it needs. But then it takes the actual letter, puts it into a completely generic, mass-produced, identical white envelope.
It standardizes the payload.
Exactly. And here is the crucial step. It then takes your original envelope, the one with your handwriting and your specific return address, and it drops it into an industrial incinerator.
It literally burns the metadata.
It physically destroys the link. So then the machine drops the new generic white envelope down a chute and out into the main sorting floor of the post office. The recipient eventually gets the birthday card. The post office, as an entity, knows a birthday card was successfully processed.
But if a rogue postal worker tries to look at that generic white envelope on the sorting floor and asks, wait, who exactly sent this card?
They can't. There is absolutely no link back to you. The chain of custody was violently broken inside that soundproof booth.
Wow, that's actually a really solid analogy. It captures the pure essence of that unlinkable constraint perfectly.
Thank you. I was workshopping that one on my whiteboard. It felt a little cloak and dagger, but it makes the point.
No, it works beautifully because it really highlights the physical separation of concerns. The utility, meaning delivering the card or categorizing it for statistics, is fully preserved, but the identity link is completely destroyed.
And the architecture part is the physical booth itself.
Exactly. It's the mechanical mechanism that ensures the separation happens reliably every single time, without exception. It's not relying on the postmaster to sign a policy document promising not to look. The physical system is built so the postmaster mathematically cannot look.
And that seems to be exactly what the Open Anonymity Project is focusing their energy on, building the schematics for that booth.
Let's touch on that name for a second, too, because the source emphasizes it. The Open Anonymity Project.
It does sound a bit mysterious, doesn't it? Like some sort of underground hacker collective.
A little bit. But the word open in that title is doing a massive amount of heavy lifting. In the world of privacy engineering and applied cryptography, open almost always implies open source or, at the very least, radically transparent standards.
Which is completely critical for trust. And going back to my analogy, I absolutely wouldn't step into that soundproof booth if I didn't know exactly how the machine inside worked.
Right, because for all you know, it's a trap.
Exactly. For all I know, it's secretly copying my return address onto the new envelope in invisible UV ink.
It is entirely non-negotiable. You simply cannot have security by obscurity when it comes to true privacy architecture. If I'm going to trust this unlinkable system with my sensitive behavioral data, I need to be able to audit the blueprints.
You need to see the code.
I need to verify that the return address is actually being mathematically incinerated and not just quietly hidden in a secondary database table for later monetization.
Right. If it's a closed source black box, I just have to take the CEO's word for it.
Mm-hmm.
And in today's data climate, nobody takes anyone's word for it anymore. We've all been burned way too many times by companies changing their terms of service overnight.
Exactly. So the fact that it is a project suggests it's a highly collaborative, constantly evolving standard. It is not just an enterprise software product you buy a license for. It's a shared methodology being built by a community to ensure that third-party verification is always possible.
Okay, so we have the core concept down. Inference without identity. We have the proposed method, which is a structural architecture rather than a software patch. And we have the source itself, an open, transparent community project.
The holy trinity of modern privacy tech.
But, and there's literally always a but in my line of work, we have to look at the practical boots on the ground side of this. Because absolutely nothing comes for free in engineering.
Everything has a cost.
Everything. If I go to my CTO tomorrow and say, hey, I read this great deep dive and I want to rebuild our entire production data stack to be completely unlinkable, she is going to immediately ask me about the costs. She's going to ask about latency, compute overhead, and performance.
As she should. There is a massive operational price to pay for this.
So let's move into a bit of a rapid-fire analysis here. We need to explicitly talk about metrics and pitfalls, because if you are listening to this right now and actually thinking about pitching this implementation to your team, you need to know the downsides. You need the fine print.
Okay, let's get into it. The first major cost is almost always accuracy. Or, to be slightly more precise about it, the granularity of your accuracy.
Right, the actual metrics of anonymity. How do we scientifically measure how hidden someone is in a database? Is it just a binary toggle like privacy equals true or false?
No, it's very much a spectrum. When you measure unlinkability, you are essentially measuring how much statistical noise you have to intentionally inject into the signal to sufficiently hide the individual. There's a foundational concept in privacy research called K-anonymity.
Okay, break that down for us. I definitely heard the term thrown around in meetings, but let's unpack how it actually works.
Sure. K-anonymity basically asks a very simple question. In a given crowd of data, how many other people look exactly like this specific user?
Okay.
If K equals 1, you are totally unique. You are explicitly identified. There is literally only one person in the data set with your exact combination of attributes.
So K equals 1 is the golden record.
Exactly. K equals 1 is a privacy failure. Now, if K equals 100, that means you are mathematically indistinguishable from 99 other people in that database.
So if I look identical to 100 other people, I am somewhat anonymous. It's a decent crowd.
Yeah.
If I look exactly like 1,000,000 other people, I am very anonymous.
Precisely. You are hiding in a massive forest. But, and here's the brutal trade-off for your CTO, if I forcefully mutate the data so that your profile looks exactly like 1,000,000 other people, the subsequent inference the machine learning model makes about you is going to be incredibly generic.
Oh, I see.
I simply cannot accurately predict your highly specific idiosyncratic behavior if I have to pretend you're just the mathematical average of 1,000,000 random users.
Right. You can't recommend that hyper-specific, obscure Japanese jazz vinyl album to me if the system has to pretend I'm just an average music listener who probably likes top 40 pop.
Exactly. The utility degrades as the K-value increases.
So the metric is a sliding scale of pain. On the far left end, you have perfect privacy, meaning pure random noise but absolute zero business utility.
The database is secure but useless.
Right. And on the far right end, you have absolute zero privacy but perfect predictive utility, which is the creepy golden record. So this user privacy architecture is essentially trying to dynamically find the optimal sweet spot right in the middle.
Yes. And the real metric for success in this project isn't just, did we successfully protect the user's identity? Because that's easy to do if you just delete the data. The real metric is, did we protect the user while still extracting a statistically useful result for the business?
And that is an exponentially harder bar to clear.
It's the hardest problem in the field.
Okay, time for the yeah but moments.
Yeah.
I'll start with the classic engineering headache. Yeah, but is it actually scalable in production?
That is always the million-dollar question for any proposed architecture.
Because if my servers have to run complex cryptographic proofs or do this elaborate burn-the-envelope routine for every single individual HTTP request, that adds massive latency. It adds CPU cycles, which translates to cloud compute costs.
It definitely does. Achieving real-time unlinkable inference at global scale is incredibly difficult right now. If your system requires a machine learning recommendation in under 50 milliseconds in order to bid on a real-time ad placement or render a web page without jarring the user, adding a heavy privacy layer that aggressively scrambled and unscrambles data might completely blow your latency budget.
So practically speaking, right now, this architecture might be much better suited for asynchronous batch processing or background analytics rather than instant synchronous user loops.
In many cases, yes. Or it requires highly specialized hardware-accelerated enclaves. Or, and this is exactly where the project community comes in, they are actively developing much more efficient, lightweight cryptographic protocols to try and bring that latency down.
Okay, here's another yeah bot for you. Yeah, but is the resulting inference even useful if it's truly 100% unlinkable?
This is the deep philosophical yeah, but.
Right, because if I can't definitively link the output prediction back to the specific user, how do I actually take action on it?
It's a great question.
Like, if the system confidently infers, hey, this user is incredibly frustrated and is about to cancel their subscription, or this user is heavily researching buying a new electric car, but the system literally cannot tell me who the user is because it's completely unlinkable, what on earth do I do with that insight? Do I just email a discount code to my entire customer base and hope the right person sees it?
That right there is the absolute crux of the entire design challenge. The architecture has to support local action without global knowledge.
Oh, that's interesting. Unpack that concept, local action.
So, in a properly designed privacy architecture, the central system might infer, statistically, that a certain session looks like an unhappy user. It does not tell the central corporate server who is unhappy. Instead, the server pushes the unhappy user mitigation package, maybe a discount code or a helpful UI prompt, back down to the user's local device.
Okay.
And the local device, like the smartphone app or the web browser, which intrinsically knows who it belongs to, locally decides whether to apply the fix based on its own local state.
Ah, I get it. So the heavy inference computation happens in the cloud, completely decoupled from identity. But the actual execution of the action happens at the edge. The server essentially knows someone out there needs help. It provides the help to the void, but it never legally knows who actually picked it up.
Exactly. It's very much like leaving a big bowl of candy out on your porch for Halloween versus personally handing a specific candy bar to a specifically identified child and logging your name. You wake up and you know the candy is gone, you know the utility was consumed, but you didn't surveil who took the Snickers.
I really like that. It forcefully shifts the balance of power back to the client side.
Which aligns perfectly with the exact phrasing of the source title, User Privacy Architecture. The end user is the center of gravity in the architecture, not the corporate server. The server is demoted to just being a dumb utility provider rather than an omnipresent surveillance master.
Let's try to really visualize the gears of this machine. I know the source didn't give us like literal command line terminal snippets, but I want to make this tangible for the engineers listening. Based on these concepts, let's conceptualize the actual software tools involved in this stack. If we were building this today on AWS or whatever, what are the literal components?
Sure, we can easily infer the required components based on the constraints of the architecture.
Tool number one has to be the inference engine itself. But it's clearly not just a standard out-of-the-box model.
No, definitely not. In this specific architecture, the inference engine is likely configured to be completely stateless regarding identity.
Stateless.
Right. It's a computational machine that accepts inputs, runs matrix math, and spits up probability scores, but it has absolutely zero persistent memory of session ID 123.
So imagine a completely isolated black box API. You throw raw data in, you get a prediction out. But the box has severe structural amnesia. Every single request it receives is mathematically treated as the very first request it has ever seen in its life.
Right. But crucially, that stateless engine alone is not nearly enough. Because if I throw in a payload that says, here are my exact GPS coordinates at 3:0 a.m. on a Tuesday, even if the API has amnesia, the underlying data payload itself implicitly identifies me.
Because there is literally only one person at your exact house coordinates at 3:0 a.m.
Hopefully, yes. So the raw data is toxic.
Which naturally brings us to tool number two in the stack, the privacy shield. Or the anonymization proxy layer.
Yes. This is the truly critical piece of the Open Anonymity Project's proposed architecture. This is the entry room of your post office analogy.
So this tool physically sits on the network between the user's client device and the stateless inference engine. Its entire job is to systematically strip, scrub, and mathematically fuzz the data payload before it ever touches the machine learning model.
Exactly. It might use advanced techniques like mixed network.
Like Tor.
Very similar to Tor, yes, where it cryptographically shuffles your data packets with hundreds of other people's data packets in transit, so the network timing and routing metadata doesn't give you away. Or, more likely for analytics, it dynamically adds noise, meaning it injects fake, randomized data points into your payload so that the inference engine gets the general statistical idea, but cannot lock onto the exact, crisp precision of your original data. This is where the concept of differential privacy comes heavily into play.
Ah, differential privacy. I was waiting for us to hit that. That's the heavy noise math.
Exactly. It is a mathematical guarantee. It dynamically adds just enough algorithmic jitter to the database query that an attacker mathematically cannot tell if a specific individual's record is present in the dataset or not.
But the aggregate statistics still somehow hold up.
Right. If you ask what is the average age of our users, you get a highly accurate answer. But if you try to ask how old is Sam, the system drowns you in mathematical noise.
So the complex integration of these two distinct tools, the Privacy Shield proxy and the stateless inference engine, is what actually creates the architecture. The proxy shield violently protects the identity, and the engine processes the behavioral intent.
And the Open Anonymity Project is likely dedicating its resources to providing the standardized protocols for exactly how these two discrete components securely talk to each other. How do you cryptographically verify the shield is actually working? How do you format the fuzzed data schema so the engine doesn't completely choke on the differential noise and crash?
It's really all about standardization, because if every startup just builds their own custom bespoke privacy shield from scratch, half of them are going to have massive zero-day holes in them.
Exactly. Rolling your own crypto is rule number one of what absolutely not to do in security engineering. The exact same logic applies here. Do not roll your own anonymity architecture. Use the project's open standards, because they have been aggressively battle-tested by thousands of paranoid security researchers.
Now, I want to tap into your professional skepticism for a minute here. We have painted a really rosy, almost utopian picture of this unlinkable future. But let's do a harsh reality check. You spend your entire career looking at exactly how these systems fail.
The security researcher in me is always obsessively looking for the cracks in the armor.
So give it to me straight. Is perfect, unbreakable unlinkability actually possible in the real world?
In pure mathematical theory, yes. In practical, deployed reality, it is incredibly frustratingly difficult. The core problem is that human data is holographic.
Holographic. Meaning what exactly?
Meaning that every little fractured piece of data contains a subtle reflection of the whole person. Even if you aggressively strip the name, the email, the IP address, and the GPS location, the mere timing of your requests might give you away. The unique cadence of how fast you physically type on your keyboard might give you away.
Oh man, browser fingerprinting. It is genuinely nasty stuff.
It is terrifyingly effective. The battery level of your smartphone, combined with your exact screen resolution, the fonts installed on your machine, and your local time zone, might form a completely unique fingerprint that identifies you out of millions of people.
And as these back-end inference engines get smarter, which is the entire capitalist goal of building them in the first place, they naturally get better at spotting these incredibly subtle correlations.
Exactly. So there is this constant escalating arms race happening behind the scenes between the inference models, which are desperate to link things, and the privacy architecture, which is desperate to unlink things.
So adopting the Open Anonymity Project standards isn't just a set-it-and-forget-it JIRA ticket. It's a continuous, active battle.
It absolutely has to be. And then there's the double-edged sword of the open aspect we praised earlier. Open is fantastic for auditing and trust, but it inherently means the bad guys have the exact same blueprints you do.
Right. If an attacker knows the exact mathematical formula your privacy shield uses to inject differential noise, maybe they can train a custom algorithm to mathematically subtract that exact specific type of noise.
Exactly. Adversarial machine learning is an entire booming academic field dedicated purely to tricking, poisoning, or breaking these exact models. So if your architecture is open source, it needs to be structurally robust enough to withstand a highly motivated attacker who knows every single line of your code.
That is the classic cryptographic gold standard, though, Kirchhoff's principle. The system should remain totally secure even if the enemy steals the instruction manual.
Kirchhoff's principle, absolutely. It's the only way to build real security.
From my side, the practical engineering side, my biggest learned failure with these systems is just raw complexity.
Hmm.
Every single time we add a heavy abstraction layer like this, a differential privacy shield, a mixed network proxy, an asynchronous verification protocol, we are injecting a massive new point of failure into the stack.
And a massive maintenance burden for the ops team.
Huge maintenance. And think about the debugging. Imagine trying to debug a critical production error when the entire system is specifically cryptographically designed to hide the source of the data.
You'd get a pager alert at 2 a.m.
Right. Hey, a critical error occurred. For who? I don't know, it's unlinkable.
That is a literal nightmare scenario for a site reliability engineer.
Yeah.
User unknown, experienced a null pointer exception somewhere in the void. Good luck.
Exactly. So the raw operational complexity is a massive barrier to entry. And here's the real architectural question. If the privacy shield cluster goes down under heavy load, does the entire application fail open, meaning it just bypasses the shield and exposes everyone's raw data to keep the app running? Or does it fail closed, meaning the entire app goes offline until the shield is fixed?
Right. That is the most critical architectural decision a team can make. And unfortunately, corporate history repeatedly shows us that companies almost always choose to fail open because executives prioritize uptime and revenue over abstract privacy guarantees.
Just bypass the proxy for 10 minutes, we'll turn the privacy back on when the load drops.
And that exact sentence is how catastrophic, headline-making data leaks happen. That is how permanent trust is lost in an instant.
So the core architecture has to be explicitly designed at a code level to aggressively resist that human urge to cut corners when the servers are on fire. It needs to be structurally resilient by default.
Resilience really is the operative word. It has to be brittle to manipulation, but resilient to failure.
All right, we have covered a massive amount of ground today. We've gone from the core paradox of the title to the golden record to the conceptual proxy tools and the nightmare of debugging. Let's try to bring it all home with some highly concrete takeaways based on the source. If you are a listener who genuinely cares about this, whether you are a back-end dev building a system or just a user worried about your own digital footprint, what are the 3 steps?
Based on the Open Anonymity Framework, step 1 absolutely has to be prioritize the architecture from day 0.
Do not bolt it on at the end.
Right. Do not build a massive linkable surveillance apparatus for a year and then frantically try to put a cryptographic mask on it 2 weeks before launch. Start with the user privacy architecture as your primary requirement. Decide during the very first whiteboard session that you demand unlinkability. If you do not bake it into the core data schema, you will literally never achieve it later. It's like trying to chemically extract the sugar out of a cake after you've already baked it.
It's permanently baked in. Step 2, then, based on our discussion, would be to rigorously define your actual inference needs.
Yes. This is all about strict data minimalism. You need to forcefully ask your product managers exactly what they're trying to predict. Do you actually need to know the user's precise GPS location to recommend a decent comedy movie? Probably not. Do you really need their legal real name and email to statically detect if their mobile device is infected with standard malware? No, you don't.
Right. Don't just generically collect everything just in case we need it later. If you collect it, it will eventually be linked. It's a fundamental law of data gravity. But if you never collect it in the first place, it is perfectly, flawlessly unlinkable by default.
Exactly. The absolute best privacy architecture in the world is simply not having the toxic data on your servers in the first place. You can't leak what you don't have.
And step 3, the final takeaway, has to be to follow the project.
The Open Anonymity Project, yes, or whatever open standards emerge in this specific space. Because this field moves incredibly fast. The offensive attacks get exponentially better every month, and the defensive architectures have to evolve just as fast. You simply cannot do this in corporate isolation. You need to be actively following the standards, the cryptographic protocols, and the broader open source community that is collectively building this.
You have to check the GitHub repos, read the dense academic white papers, and stay in the technical loop. It's absolutely not a framework you can just learn once in a boot camp and blindly apply for the next 10 years.
It is a highly active, living discipline.
So, zooming out, what does this all actually mean for us as users? It means we might theoretically be moving toward a future where our devices are incredibly smart, where they know our habits and our needs better than we know ourselves, but the giant tech companies that manufacture those devices technically know absolutely nothing about us.
which is a remarkably hopeful, optimistic vision for the future of tech. It conceptually restores a little bit of fundamental digital dignity to the user.
It really is. It's like having a brilliant, world-class butler who is incredibly helpful and anticipates your every need, but has absolutely no long-term memory of who you are or what your name is.
The perfect, highly secure employee.
I was just thinking, though, applying this to everything, I would love to see someone try to build a truly unlinkable corporate email system.
Oh, God, the chaos.
Right, your inbox pings, you have an urgent message, you ask, well, who is it from? The system says, I have absolutely no idea, the identity was incinerated, but based on the differential inference, it is highly urgent.
That sounds like my absolute worst nightmare. You get a notification saying, someone in your life is extremely mad at you. You ask who. The system says, we mathematically cannot legally say, but the localized sentiment analysis is absolutely furious. Good luck.
Maybe, just maybe, some specific things really do need persistent links.
Just a few. I think we can safely keep the primary keys for the things that matter personally, like human communication.
Well, that is unfortunately all the time we have for this deep dive. We heavily rely on you to keep this conversation going. Find your weirdest, most obscure edge case for unlinkable architecture and share it with us. We genuinely love geeking out over this stuff.
Yes, please do. Where does the unlinkable concept completely break down for your specific industry? Or conversely, where do you desperately wish your industry had it implemented yesterday?
Tell us what complex topic to cover next. Leave a comment and a rating wherever you listen, and subscribe if you enjoyed the deep dive. Thanks so much for listening.
Until next time.